Today we're going to do a word problem that is looking for the greatest common factor. So our problem says, you're filling piñatas for your friend's birthday party. The list shows the gifts that you're putting into the piñata. So here's our list. You want identical groups of gifts in each piñata with no gifts left over. What's the greatest number of piñatas that you can make? All right, so we have 18 kazoos, 24 mints, and 42 lollipops. And we want to fill as many piñatas as we can that all have the same number inside. So really, we're going to be looking for the greatest common factor of these numbers. So we're going to find our greatest common factor using prime factorization. All right, so I'm going to make factor trees for 18, for 24, and for 42. All right, so 18, I'm going to do 3 times 6. 3 is prime. 2 times 3 is 6. All right, so I have 18 is 2 times 3 times 3. Let's find our prime factorization for 24. Let's do 6 times 4. Neither of those are prime. I'm going to keep going. 2 times 3. 2 times 2, all of those are prime. So 24 would be 2 times 2 times, times 2 times 3. And then lastly, 42. I know 6 times 7 is 42. 7 is a prime number, so I get to circle him. Break this down. 2 times 3. 2 times 3. So 42 equals 2 times 3 times 7. Now, I have 3 numbers here that I am going to try to find my greatest common factor of. So I want to find my common prime factors of 18, 24, and 42. So what I'm going to do is I'm going to see which repeats. Every one of these has a 2, so I'm going to circle all of the 2's. And I notice that every one of these has a 3. So I'm going to circle my group of 3. So together, they are the greatest common factor is 2 times 3. So our greatest common factor here is 6. So we can fill 6 piñatas. We can fill 6, I'm going to put it up here, 6 piñatas. All right, so that is how we can find the greatest common factor of more than 2 numbers, and we've also solved a word problem finding the greatest common factor.